Hello, cosmic explorers. Ready for a trip to Venus, our mysterious and somewhat moody neighbor? Today, we're diving beyond the sulfuric acid clouds to discover what makes Venus a place that's both fascinating and fearsome. From mountains that rival Everest to a day that lasts longer than a year, we promise that Venus will amaze even the most seasoned astronomy buffs. So buckle up, because our ship is departing now. Observations of Venus date back over 4,000 years when the Babylonians already recognized the planet, naming it Nindarana. The perspective on Venus has evolved significantly over the centuries, with the Greeks and Romans providing distinct names based on its appearances in the sky. The Greeks called it Phosphoros when seen in the morning, and Hesperos in the evening, while the Romans unified these identities under the name Venus, the goddess of love. These designations reflect not only an astronomical observation, but also a rich tapestry of mythology and culture that intertwines with scientific understanding. In the 17th century, observations of Venus took a significant leap forward with advancements made by Galileo Galilei and Giovanni Cassini. Galileo, using his telescope, observed that Venus exhibited phases similar to the Moon, a finding that strongly supported Copernicus's heliocentric model, suggesting that planets orbit the Sun. Cassini, in turn, made detailed observations of these phases, further consolidating evidence in favor of the heliocentric system, marking a turning point in our understanding of our solar system. The exploration of Venus entered a new era with the advent of the space age in the 20th century. Significant missions like the USSR's Venera probes, which not only achieved the first successful landings on another planet, but also sent the first direct images from Venus's surface, dramatically expanded our knowledge about the planet. Moreover, the US Magellan mission, by mapping Venusian topography using radar, and Japan's Akatsuki mission, focused on studying Venus's atmosphere, contributed immensely to understanding the physical and climatic features of Venus. The second planet from the Sun exhibits a fascinating astronomical peculiarity. Its day is longer than its year. With an extremely slow rotation on its axis, Venus takes about 243 Earth days to complete a single spin. This slow pace starkly contrasts with most celestial bodies in our solar system, which typically complete a rotation in a much shorter period. The Venusian year, the time it takes for the planet to complete an orbit around the Sun, is surprisingly shorter than a Venusian day, lasting about 225 Earth days. This unusual situation occurs because Venus has one of the slowest rotations among all the planets in the solar system, coupled with a relatively quick orbit around the Sun. As a result, the planet experiences fewer days in a whole year than we do on Earth. Another intriguing feature of Venus is the direction of its rotation. While most planets in our solar system rotate from west to east, Venus does so from east to west. This phenomenon, known as retrograde rotation, is yet another peculiarity that distinguishes Venus from its planetary neighbors. Venus's retrograde rotation means that the Sun rises in the west and sets in the east, the opposite of what is observed on Earth. Is one of the few planets in our solar system that stands out for not having moons, a feature it shares only with Mercury among the terrestrial planets. The absence of moons on Venus has intrigued scientists and astronomers for decades, as there is no clear consensus on why this phenomenon occurs. While Earth has one moon and Mars has two, Venus remains solitary in this regard, raising various questions about the conditions and events that shaped its planetary environment. Various theories have been proposed to explain why Venus lacks natural satellites. One hypothesis suggests that Venus might have had moons in the past, but cataclysmic events, such as large collisions, may have removed these celestial bodies from its orbit. Another possibility is that the strong solar gravity, due to Venus's proximity to the Sun, could have prevented the formation or stabilization of moons around the planet. The study of Venus's features in comparison with other celestial bodies also provide insights into this uniqueness. For example, Venus's intense volcanic activity and dense atmosphere are factors that significantly differentiate Venus from other planets and may have influenced its ability to capture or retain moons. The dense atmosphere and proximity to the Sun might have contributed to an environment less conducive to stabilizing smaller bodies in its orbit. Venus is a planet that fascinates scientists not only for its extreme atmospheric features, but also for its remarkable volcanism. With over 1,600 confirmed volcanoes, Venus has the highest number of known volcanoes of any planet in our solar system. This feature suggests intense geological activity that may still be occurring. Detailed studies of the Venusian surface show a variety of volcanic forms, including huge shield volcanoes and complex volcanic complexes that are testimonies to a rich and dynamic geological history. Evidence of recent volcanic activity on Venus is particularly intriguing. Space missions and radar observations have detected not only volcanic structures, but also surface changes that suggest recent eruptions. The possibility of active volcanism is reinforced by phenomena such as variations in the amount of sulfur dioxide in the upper layers of the atmosphere, which some scientists associate with the release of volcanic gases. This indicates that Venus is not just a geological museum, but a planet that is still actively shaping its own surface. Understanding volcanism on Venus is crucial not only for unraveling the geological history of the planet, but also for understanding broader planetary processes. Volcanism can impact planetary climates through the emission of gases into the atmosphere, potentially altering atmospheric compositions and influencing habitability conditions. In the case of Venus, intense volcanism may have been one of the factors that contributed to its extreme greenhouse conditions, with surface temperatures high enough to melt lead. And so we conclude our Venusian expedition, Intergalactic Friends. I hope you enjoyed unraveling the secrets and peculiarities of Venus as much as I did. Remember, the universe is filled with mysteries and wonders, and each planet has its own fascinating story to tell. Don't forget to hit like, subscribe to the channel, and turn on the notification bell for more cosmic journeys like this one. Until next time, when we'll explore another incredible corner of our solar system. Stay curious and always be ready for the next cosmic adventure.